right-angled triangles, and the Pythagorean theorem. Let's review. What are the different types of triangles we know? Take a minute and write them out. If we add up all the angles in a triangle, what does that add up to? In today's lesson, we will talk specifically about the right-angled triangle. Let's begin by talking about what a right-angled triangle is. A right-angled triangle is one that has a right angle in it. A right angle is 90 degrees. Here's a picture of what one looks like. Taking a closer look. The longest side of the triangle is called the hypotenuse. It is also the shortest distance between 2 points as long as they are not directly across from each other. The hypotenuse can be found directly across from the right angle. The other two sides can vary in any length and don't have a specific name. Let's try an investigation. On your paper, there is a right angle triangle. Measure each side of the triangle. Make a square box on each side. The length of each base should be the length of each box. What do you notice? If we add up the area from the two smaller sides, it equals the area of the hypotenuse side. The Pythagorean theorem. Through our investigation, we got to see the Pythagorean theorem in action before we even knew what it was. The actual theorem states that in a right-angled triangle, the length of the first side, which we call A squared, plus the length of the second side, which we call B squared, will equal the length of the hypotenuse, which we call C squared. If we write this as a formula, it will look like this. A squared plus B squared equals C squared. Let's watch a short video highlighting what the hypotenuse can do. On the left, we have Chantal. Chantal is going to represent the hypotenuse in this situation. On the right, we have Jasmine. Both girls are going to cross the street and make it to the stop sign. Let's see who makes it there first. Both girls will check to make sure it's safe before crossing the street and head in their own separate directions. Let's take a look at this from a two-dimensional perspective. Chantal will be represented by the blue line and Jasmine will be represented by the red line. We can see that Chantal walked a shorter distance and got to the stop sign faster. Notice how Chantal made it to the stop sign before Jasmine. That's because she's the hypotenuse. Remember from earlier we said that the hypotenuse was the shortest distance between 2 points as long as they were not directly across from each other. Way to go, girls! Now let's watch and see where we can find the hypotenuse in real-life situations. After successfully crossing the street safely, Chantal and Jasmine decided to play a game of basketball. Let's watch and see where we can find triangles in our everyday life. First, we'll watch Chantal shoot a basketball. Did you see the triangle? Well, let's take a look at what happened. The basketball pool makes a right angle with the ground. When Chantal was shooting, she was shooting across the hypotenuse. To find out how far the ball was traveling, we could use the Pythagorean theorem. For example, if the basketball net is 5 meters high and Chantal is 6 meters away from the net, how long was the path the ball traveled? Solution. If we let A be the height of the basketball net and B be the distance Chantal is away from the net, we can use the Pythagorean theorem. Remember, the Pythagorean theorem states that A squared plus B squared equals C squared. So, 5 squared plus 6 squared equals C squared. Solving for C, we get that C is approximately 7.81. So Chantal shot the ball and it traveled 7.81 meters. Try and spot the triangle in this next video as the girls do a simple pass and shoot play. Let's draw a diagram to see things better. As we can see, when Chantal passed the ball to Jasmine, she made the first side to a triangle. When she ran across the bottom of the key, she made another side of the triangle and made the right angle corner as well. When Jasmine passed the ball to Chantal, she passed it along the hypotenuse. Here are some numbers so we can see how to use the Pythagorean theorem with this triangle. If we said the key was 3 meters long and the ball traveled from Jasmine to Chantal over a distance of 4 meters, how wide is the key? Solution. If we let A be the length of the key and C be the distance the ball traveled from Jasmine to Chantal, we can use the Pythagorean theorem. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared. So, 3 squared plus b squared equals 4 squared. Solving for b, we get that b equals approximately 2.65. So the width of the key is about 2.65 meters. Good job, girls. Way to demonstrate how we use math in everyday life. Congratulations! You've made it to the end of the video. You now know how to use the Pythagorean theorem and the hypotenuse. You can successfully use both of these to calculate distances and lengths of different objects. Now refer back to your teacher for instructions on what to do for the rest of today's lesson.